Morning, everyone, and welcome to the seminar today. And today we've got a special speaker, Professor Jun Zhou from Griffith. So Professor Jun actually got a whole his career on computer science. So this is a very interesting piece of interdisciplinary research looking into how computer science can contribute to conservation. So I'll give the,
Okay.
Professor Zhou can introduce the word.
Yeah. Thank you very much, Becky. Well, it's my great pleasure to have the opportunity to come here and give this seminar to CBCS. So you'll see that's what we have done. It's about Koala recognition and tracking. This is the title of my talk, AI for Koala Road Crossing Behavior Monitoring. It's a project funded by the Queensland Department of Environment and Sciences under its Community Sustainability Action Grants, Round 4, Koala Applied Research in Southeast Queensland. I'll give a little bit about the background of this project, although I believe most of you here are more experts than me in this area. So, well, koala is the most iconic animal species of Australia. However, over the past years, we have seen a quick drop on the population of wild koalas. So there has been an estimation from CSIRO, but back to about 10 years ago, there was about 180,000 koalas in the southeast coast of Queensland, but this number dropped to an optimistic estimation of 58,000, as reported by the Australian Koala Foundation last year. So this is particularly the problem in Queensland and New South Wales, where the koala's population declined by 50% or more over the last 2 decades, and especially after 2018, the bushfire, we have seen about 30% drop in the whole Australia on the koala population. So that's why earlier this year, the federal government lifted the species from into endangered level. So if we look at the reasons for koala population decline, the highest one is the habitat loss, and then there's the drought, the bushfire, disease, car strike, and dog attack, and so on. We are particularly interested in the car strike as one of the reasons for the koala population decline. We've done a quick analysis on the government database. So we found from 1997 to 2018, an average of 356 koalas entered the care facility each year in Southeast Queensland only, due to the vehicle collision. So therefore, mitigating koala fatalities and injuries caused by vehicles is one of the most important tasks for koala conservation. Of course, in order to know how to mitigate the fatalities, we need to understand koala's road crossing behavior. So that requires new technology to be developed in order to be able to recognize koalas, to see when, where they cross the road, and if possible, make predictions. So if we look at the current technology available for koala monitoring and population analysis, over the past years, like GPS and VHF tracking, koalas, radio frequency identifications, and drone and camera traps have all been used. So among these technologies, the GPS and VHF tracking koalas have some unique advantages for continuous monitoring of the koala movement. However, this technology is intrusive, right? You have to capture the koala, and in order to put the koala on or tag on the koalas. And also it's limited to the known koalas only. If we have new koalas in the area, coming to the area, or newborn koalas, we'll not be able to monitor it. Then the drone-based technology has also been used to fly over the trees to see koalas hanging on the tree. The main problem is it's not going to provide this continuous monitoring capability. Right? You have to fly it, and it's not that convenient to, for example, fly it over the night. Camera traps is another technology that have been used. I believe probably some of you have used here. It can provide continuous monitoring capability, but it's limited on its range that can be monitored. So if we want to adopt the technology for a large area, we need to put many camera traps there in order to increase the coverage. Then it caused a problem, like how can we access the data? How can we analyze the data? So over the years, researchers have to go to the camera regularly to retrieve the memory stick or copy the data to their computer, and then go to their office, go to their home, and watch each image or videos in order to be able to analyze whether there's a koala in it, right? So that's a huge task, tedious task, requires a lot of time and efforts. So that's the motivation of our project, that we want to use the recent advances in computer science, in sensor technology, to provide a platform for automatic koala data capture, data streaming, data analysis, and the reporting, right? So this is built on the most recent advances in artificial intelligence. Over the past years, we've seen great increase on the capability of the AI in helping to recognize objects, to classify different types of objects, including animals in different species. So we've seen this graph showing the capability of the recognition accuracy increase over the past 10 years, and also the increase on the computation capability provided by the modern computers and the parallel computing capabilities, especially empowered by the like NVIDIA, these GPU clusters. So we designed this framework to do the job. The goal is to automatically capture images and videos in the wild or any location that we are interested, so that we can automatically detect whether we have seen a koala, or whether we have seen anything moving in the image or videos in front of the camera, whether it's an animal that caused the trigger of the image, and whether this animal is a koala. And so for these first two recognition tasks, we have already completed them. And now we are working on detecting individual koalas. We're trying to figure out whether it's the same koala passing the camera. Okay. So in general, the system is composed of different components. So here you can see that we have this camera trap there. This camera trap has a motion sensor. So whenever anything moves in front of it, it will trigger the capture of an image or a video. And then the captured image will be sent to our server through a 4G network. So the images will be attached as the attachment of an email and sent to our email server. Then we have a program to automatically grab the attachment and put it on our own computers. And then we have the AI running automatically to process these received images and videos. So we can to figure out, okay, whether there's a koala in it. The whole process is fully automated. So this is the camera that we currently are using. It has a camera to capture images and the videos in different resolution. It can capture videos at the highest resolution of 1080 pixels in the image. It can be triggered during the day and work at night. It has its own internal light source, infrared light source to illuminate the scene at night. We can set up the length of the video, and we can also set up the working hours for the cameras. So in order to train the AI, we need to get a lot of labeled images, right? So we need to tell the AI, okay, this is a koala, okay, or this is a kangaroo, right? So in order to do it, we got the help from a lot of collaborators. So you can see their names here, including UQ. So who provided us with the opportunity to install cameras and capture their koalas, or provided us with data sets they have collected over the years. Yeah. So after we have, these are two examples that we set up cameras in the Daisy Hill Koala Center and Long Pine in order to capture the koalas there, right? So that's the easiest way to capture koalas, because they are too difficult to observe in the wild. And after we have collected enough sufficient number of images and trained the AI, then we deploy cameras in those animal paths, right? Underpass or overpass. So these are the areas that provided by the Redland City Council, the Brisbane City Council, and the Koala Action Group in Redland at Queensland Rail. So these are the interesting locations that we want to monitor to see whether koalas are using the animal paths there, or they are using the shared paths between for animals and pedestrian. So this slide shows some examples on the installed cameras. So we also provided solar panels connecting to the cameras to make it work longer, for longer time, so that it's not going to rely purely on the battery. So far, the camera that has worked for longest time is now 1 year and 4 months without need to replace the battery if they are powered by the solar panels. But without the solar panel, maybe 3 to 6 months, depending on how frequent the images and videos have been triggered. So at each location, we also put a sign here to show, okay, to let people know this is for the Koala monitoring project. And we also provided a QR code here so people can scan and upload the images they captured. Right? So we make it a citizen science project. There are some challenges in the data collection process. So the first challenge is caused by the natural environment, like for example, the flood, right? So this is one image we captured on the 20th of February this year. Then 5 days later, it becomes this because we had the flood. And then this was captured at 5 a.m., 5:47 a.m. Then after that day, we lost connection with this camera for a whole week. We thought, wow, the camera is gone because it's on the water. But then surprisingly, on the 2nd of March, it started to send videos again. Right? So which shows it's really waterproof very well, even if it's on the water. And another problem, of course, is the weed, right? So they block the view, and also if they're heavy overgrown, the animals will not use the paths. So a lot of job we need to do is like this. We go there and clear the weed. So it took us a lot of time and efforts So this is at the animal overpass at the Illaweena Street next to the Karawasa forest. So we had to go and cut the grass. So you see, as a computer scientist, this is our normal working environment, in a modern fancy room with computers. But this is actually what we have to do for this project. Right? We have to cover our body with long sleeve clothes, and then use the size to go and cut the weed. So that's some very interesting experience we got from this project. Yeah. Yeah.
They're asking where the QR code from the science goes to. Is it connected to the existing citizen science reporting programs?
Okay, so yeah, the question here is where the QR code leads to. So the captured images, where they're going to be sent. They're going to be sent to a Sharepoint at Griffith University. Yeah, so that's, we have a folder to store them. Yeah. Okay. Yeah. Okay, I'll continue. Yeah. So we also learned during the process that it's pretty rare to capture koalas during the day. So that's why we set the camera to work from 5 p.m. to 8 a.m. for most of them. Yeah. And initially we set the camera to capture images, and we find many of the images are empty because the animal moves very fast in front of it. So there will be a delay from the trigger of the camera to the time where the image is actually captured. So then we set the camera to capture videos instead of images. I want to show you a small demo of the two data management tools that we have developed to manage the data captured from this project. So the first one is this dashboard, which allows us to monitor the data captured every day. So we have all these locations showing where the cameras have been installed. And if we click one of the locations, for example, Birkdale, then you'll see from Birkdale, in total, more than 10,000 images or videos have been captured from which camera. And then here we also show the time of captured images and videos, and the status of the battery, and also the status of the mobile signals. At the bottom, it's a statistics showing the images captured or videos captured from each camera. And then we have another app called Koala TV. So it's a tool to enable us to see in real time the captured images and videos. So we can select the location. For example, this is Wellington Point and camera 005. And this was the data captured yesterday. And this video, it shows a possum being captured by one of the cameras. I don't know why it's standing vertically. Probably want to change it to a human. So, so there's a hole here. Next to the fence is the railway at the Wellington Point. So this is a location pointed out by the Queensland Rail. They want to see whether koalas or other animals are using the hole to cross the fence, cross the railway. So there are quite a few holes. So we put one camera at each of the hole there to see whether animals are using them. So we can have a look at some other videos. It's an hour, is it? Oh, I don't know. Yeah. So you see, many of the videos are like this. So we look at it, there are nothing moving there. So possibly it's caused by the movement of the trees and the grass, or maybe the animal moves very fast. So it's not captured by the camera. So if we go back to the Koala videos app here, so we can see that in total from last April or May till now, we have captured more than 77,000 images and videos. So it's a huge amount of data to analyze. If we do it manually, it would be too tedious task. Okay. So this slide shows some of the locations that we have deployed the camera. So this is Compton Road. Next to both sides are the Karasa forest. So we put 5 cameras here to monitor this animal overpass. This is a new overpass built several years ago at the Illaweena Street, which is also next to the Karasa forest. So see from the aerial image, there are not many vegetations on the bridge, but actually it's heavily weeded. It's even very difficult to walk across them. And then this is at Birkdale. It's a pedestrian path under the railway shared by human and animals. And this is Cleveland, and next to the railway. Oh no, sorry. It's the highway at Cleveland. So we're monitoring the animal paths underneath the bridge. Yeah. And that one as well. So we developed our own tools to provide the labels because we need to get labeled image to train the AI. So in this tool, we can outline the location of the interested objects and using this bounding box. So then this part of the image will be cropped out as the input to our machine learning model. We labeled in total, that's the old data. That's the first, in the first 3 months of the data labeling, we labeled about 20,000 images, which contains more than 16,000 instances. So you can see the split on the number of images we labeled for each category. So these are the categories that we are interested in detecting and recognizing in the Southeast Queensland region. The main labeled objects are koalas captured from the animal sanctuaries or zoos. And then we have a lot of people, kangaroos, possum, birds labeled as well. Then the actual recognition model was implemented using a very popular object detection model called YOLO. YOLO has different versions. We used version 5, and this year, just last month, the latest version, V7, was released. It's a model based on deep neural networks, which works like the human brain, right? With many connected neurons, and then between the neurons, there are the connections with weights. So similar to human brain, in order to train us brain to recognize some objects, we need to be able to see the images and be told, okay, this is a particular object, then we know, okay, this is a particular object. So in order to train the neural network, we need to feed them with a large amount of images. If we look at the Google or Amazon or Facebook object recognition engine, they normally train the neural networks with billions of images. So it's impossible for us to do it. So what we do is to use this pre-trained model, train on those billions of images, and then retrain it using our Koala images so that we can update the recognition engine to let it recognize koalas and other animals that we are interested in. We tested our train model on 1,800 videos collected in December last year. And each video was 5 seconds with 150 frames. And we found the engine that we developed can achieve about 93.9% accuracy, so which is pretty good. So here are some examples on the tracking results. So these slides shows the videos we captured at the Daisy Hill Koala Center. So these koalas are walking underneath this deck. So we found there were 2 koalas walking underneath the deck every night. I don't know, maybe for exercise purpose. Yeah. And then these are the videos captured at the Long Pine Koala sanctuaries. So you see the good thing of this detection engine is it can detect multiple objects in the image. And even when these koalas are heavily occluded by the tree, by the branch, by something, it still can detect them reliably. And these are some examples about koala detection in the wild. These 3 videos were captured at the Compton Road, where we put 5 cameras. So you can see, like this one, the first one was captured on the 29th of August last year. And then we captured the same koala on the 19th of September. And then again on the 4th of October. But on this last video, we can see the koala was crippling. There was some injuries on the leg. So we reported this case to the Brisbane City Council. Hope they can go and help the koala. We also captured many other animals like foxes. We saw a lot of foxes. And then the possum. This one was very interesting. We see this small possum for many times when it was very small to this big one, big size. A lot of wallabies. And this is, I don't know, iguana or what? Yeah, okay. So currently we're working on individual koala detection. We have trained a koala image recognition module based on the images provided by the Queensland Department of Environment and Sciences, by the Koala Action Group from Redland, and also from the University of Sunshine Coast. So this individual recognition engine was also based on deep neural network, and which worked quite reliably for images captured during the day, but we're still struggling to make it work for the images captured at night because the resolution of images like this is too low. Okay, so finally, I would like to introduce the team for this project. I have Dr. William Tan, who is an expert in sensor network. So he's in charge of deploying the cameras, the setup the cameras, maintenance of the cameras. Douglas Curling and Guy Kirstlees are from our School of Environment and Science. I think Douglas is going to join UQ quickly, very soon. And Guy is in our Gold Coast campus. Cass Dexter is from the Red and Silk Council. She looks after the koala conservation program in Redland. Firsthell and Owen are my students. So they helped to develop this AI recognition engine. Daniela developed those two data analysis apps, the dashboard and the Koala TV. She's from our e-research services. And Rob Appleby is our partner from the industry. He has heavily involved in koala observation in the Redland and broader Southeast Queensland area. So I would also like to thank all the collaborators for this project. Okay, that's all my talk.